Welcome to the DIY Honda Garage channel. The DTC codes P1172 and P1174 relate to issues with the air-fuel AF sensors in the Honda Odyssey models between 2011 and 2017. Specifically, P1172 indicates rear AF sensor, bank 1, sensor 1, circuit out of range, high, and P1174 indicates front AF sensor, bank 2, sensor 1, circuit out of range, high. AF sensors are crucial for monitoring the air-fuel ratio in the engine, helping optimize combustion for performance and emissions. They are located in the exhaust system, with sensor 1 positioned before the catalytic converter, allowing the engine control module, ECM, to receive real-time data. When these sensors report higher than expected values, it can lead to poor engine performance and increased emissions. Understanding these codes will inform whether to continue troubleshooting, replace a sensor, or check for wiring issues. The DTC P1172 refers to the rear air-fuel sensor for bank 1, signifying that this sensor's circuit is recording values that are high, which could indicate a malfunction or sensor failure. Bank 1 is generally the side of the engine that contains cylinder 1. P1174, on the other hand, refers to the front AF sensor for bank 2, which is similarly meeting high circuit values, indicating issues. These sensors perform critical roles in evaluating the air-fuel mixture being sent to the engine. They are located in the vehicle's exhaust system after the engine, with sensor 1 positioned upstream of the catalytic converter. Their primary function is to provide feedback to the engine's control systems, allowing for adjustments in fuel delivery and ensuring optimal engine operation. When these DTC codes appear, it is essential to investigate both the sensors and the wiring for potential faults or disconnections. Several factors can lead to the occurrence of DTCs P1172 and P1174. A primary suspect might be faulty air-fuel sensors. Over time, these sensors can degrade due to exposure to high temperatures and exhaust gases. Additionally, poor electrical connections are another potential cause. This can be due to corrosion, dirt, or loose terminals, affecting communication between the sensors and the ECM. Wiring issues can also prevent accurate readings, leading to errors in air-fuel mixture adjustments. The powertrain control module, PCM, could potentially cause problems if it fails to interpret the sensor data correctly, leading to poor engine performance. It's essential to examine these possible causes during the diagnostic process thoroughly. The symptoms associated with DTCs P1172 and P1174 can be significant and noticeable. First and foremost, the check engine light, CEL, will be illuminated on the dashboard, signaling that an issue is present with the vehicle's emissions system. Drivers may also experience rough engine performance, which can present as erratic idling or hesitation during acceleration due to an incorrect air-fuel mixture. This can lead to a decrease in overall engine efficiency, reducing fuel efficiency and potentially increasing exhaust emissions. Furthermore, drivers may notice unusual engine behaviors, such as stalling or poor throttle response. These symptoms collectively indicate that the air-fuel sensors need to be investigated for potential faults. The first step in troubleshooting the DTCs P1172 and P1174 involves turning the ignition switch to the on position. This should not be confused with starting the engine. It's merely a preparation phase for diagnostics. It's vital to record all relevant freeze data and onboard snapshots prior to beginning any repairs or tests. This data can provide valuable insight into the vehicle's recent performance and any specific conditions that triggered the error codes. Additionally, Reviewing the general troubleshooting information is essential, as it provides context and guidelines specific to handling AFAT sensor issues. Ensuring that you've got the complete picture before proceeding helps in diagnosing and finding a solution more effectively. In this second troubleshooting step, you will use the Honda Diagnostic System, HDS, to clear the previously recorded Diagnostic Trouble Codes. Clearing the DTCs will reset the fault indicators, allowing you to start fresh. After clearing, start the engine and hold the engine speed at 3000 RPM without load, such as being in park, P, or neutral, N. This action runs the engine at a high enough RPM to trigger various sensors and allows you to monitor the operational performance. As the engine idles, keep an eye on the onboard diagnostics OBD status for any indications of DTC P1172 and or P1174 to determine whether the error codes continue to persist. The HDS will indicate if the system passes or fails, guiding subsequent troubleshooting steps. At this point, you will review the results presented by the Honda Diagnostic System HDS. If the HDS indicates failed, this requires you to proceed to step 5 in the troubleshooting process. This typically means that the fault has not been resolved and further investigation into the circuit or sensor is necessary. In contrast, if the HDS displays a passed status, this might suggest an intermittent failure, indicating that the system appears functional at this moment. However, even with a passed status, it is prudent to check for any poor connections or loose terminals at the AF sensor, Sensor 1, and the Powertrain Control Module, PCM. Ensuring secure electrical connections can eliminate a common source of issues in these sensors. Following the checks from the previous step, if the HDS indicated failure, you will need to turn the ignition switch to the lock 0 position, thereby shutting off the engine completely. This step is crucial for safety whenever performing electrical repairs. Next, replace the AF sensor, Sensor 1, that corresponds to the diagnostic codes in question. Obtaining a suitable replacement part is critical to ensuring that the car detects accurate readings moving forward. After replacing the sensor, turn the ignition switch back to the on second position in preparation for further electrical tests and resets. This reinitialization of the system is a vital step in confirming the effectiveness of your repairs. After successfully replacing the air-fuel sensor, the next step entails resetting the Powertrain Control Module, PCM, using the HDS. Resetting the PCM clears any existing fault codes and allows the module to recalibrate to the new sensor conditions. After performing the reset, it's important to execute the idle learn procedure. This procedure helps the PCM adjust its parameters based on the new inputs from the AF sensor for optimal engine performance. Once completed, start the engine and hold it at 3000 RPM without load to allow the system to recalibrate fully while monitoring the sensor readings. This step ensures that everything is functioning correctly, setting the stage for a successful diagnostic outcome. In this step, you will monitor the onboard diagnostic system for any pending or confirmed DTCs. Be sure to utilize the HDS to check if DTC P1172 or P1174 are still indicated, as this will guide your next actions. If either code is present, focus on checking for poor electrical connections or loose terminals at the AF sensor, Sensor 1, and the PCM again. This repeated inspection is crucial as it can reveal persistent issues that require attention. Following this, you would proceed to troubleshooting Step 11, where you will again assess the engine performance and sensor functionalities, ensuring that all potential sources of failure have been thoroughly examined. In this crucial step, you will proceed to monitor the OBD status within the DTC's menu using the Honda Diagnostic System, HDS. This monitoring will help to confirm whether the newly reset system has accurately detected any further issues. If the HDS indicates a passed status for DTC P1172 and P1174, this generally means that the troubleshooting is complete and the system is functioning as intended. However, be sure to pay attention to any new or other pending DTCs that might have emerged. If failed is indicated, further analysis is needed, focusing again on potential connection issues or circuit faults. Should the system indicate either executing or out of condition, further diagnostic protocols should be initiated as per the previous troubleshooting steps. The final repair verification phase is crucial to ensure that all troubleshooting efforts resulted in a successful fix. First, revisit all sensor connections and terminals to ensure they are secure and free from corrosion or damage. A thorough inspection of all wiring is essential to confirm that everything is in good condition. A test drive may be warranted to execute various driving conditions and ensure the ECM and sensors operate correctly under real-world conditions. It's also important to conduct a final check using the HDS to verify that no DTCs are present and that the system has returned to a normal operational status. Confirmation that all error codes have cleared and that the vehicle is operating seamlessly indicates a successful repair process. Preventive maintenance is essential to prolong the lifespan of the AF sensors and the overall engine management system. One effective measure is to regularly check the integrity of wiring and electrical connections associated with the AF sensors. Over time, wear and tear can lead to compromised connections, which could cause future issues. Additionally, performing routine tests on the sensors can help identify any deviations in performance before major issues arise. Scheduling regular maintenance visits based on the vehicle's usage can help prevent sensor failure and related DTC emergence. By following a proactive approach to these components, drivers can help ensure their vehicles operate efficiently and reliably. In conclusion, understanding the significance of the AF sensors and their roles in the engine management system is essential for maintaining the Honda Odyssey from 2011 to 2017. The presence of DTCs P1172 and P1174 indicates underlying issues that must be addressed through a structured troubleshooting approach. Monitoring the condition of connectors and wiring is crucial, as these can be common fault points leading to sensor failure. Regular maintenance of these components can help prevent recurrent issues and ensure the vehicle operates at peak efficiency. Awareness of this process equips vehicle owners with the knowledge to maintain better performance, reliability, and compliance with emissions regulations. Please like and subscribe to the channel. See you next time.